What's up, YouTube? What's going on? My name is Laxativity, and today I'm going to be explaining the science behind the time travel in Avengers Endgame. I'm going to try to make this as simple as possible and as fast as possible because I don't have enough storage on my phone. So, let's get into it. First, Avengers Endgame, the time travel has something to do with something called quantum mechanics, which deals around time microscopic atoms that are like in the quantum realm in Avengers Endgame. But this is real. Microscopic atoms just floating around inside of the mass of of actual physical things. So there's something in there called quantum tunneling, where this is all completely real except for when I say Avengers Endgame. So this is real quantum tunneling. Imagine this: inside the object or somewhere, there's a point where it's called X, and then to the left it's just nothing. It's not nothing, but it's just infinity, just particles. Right here and right here. This is a part of a barrier. That I'm gonna call O. This barrier is a barrier because it keeps from the particles going over and crossing through it. So from this so there's this one and this one, but there's also another part of the barrier because it's like a wall. The other part of the barrier. So and then after that, to the right, it's just infinite particles like X. So yeah, I'm gonna have to go very quickly on this one. Um, waves. Waves are part of something called probabilities or chance or possibilities, where imagine you have a ball, okay, in a very small hill. This deals with kinetic and energy because when you roll the ball, it easily gets up the hill. The possibility in that is one because it'll always go up the hill no matter what you do. Now, say it's a bigger hill, and you roll the ball, and then it stops, and then it goes back down. From when it goes all the way up, as soon as it stops, that probability hits zero because of how it just stops but then goes back in the direction it came from. If it went over, the probability, like I said, would be 1. So it's like kinetic energy, it's moving up, but as soon as it stops or goes somewhere, it immediately turns to the probability of 1 or 0, and then immediately goes. Probability of 0 is when it just doesn't go up the hill. It stops, and then probability hits 0 because it will never get up the hill, and then it rolls back down. So, from within this, quantum tunneling is when no matter what you do, it stops no matter what you do, but somehow it made a way to the other side. And that is kind of hard because it was impossible. That's quantum tunneling. Quantum tunneling, going back to the other equation with x, o, and let's just call the other part of the barrier just L. X, it's x, quick. X is where the particles are. Quantum tunneling, just like the ball, the atom somehow makes it through the barrier to the other side. But although it could make it through the barrier, there's almost a 0% chance it could go back. So, like I was saying, X and O have a probability of 0 because it has no chance. The probability between O and L is 1 because it's part of the barrier. And just like the ball, if it goes up, it goes down. So, oh crap, I forgot about the wavelengths. Right, wavelengths. The wavelengths are frequencies inside of those microscopic atoms, in where it's determined on the probability. So from X to O, it's there's nothing because that's not probability. Wait, from O to L, it's higher because it has a high probability. So if it goes through it, those wavelengths are disturbed, making it, therefore making the atom go through the actual barrier, but it can't go back through because the wavelengths have already been, because the wavelengths are just already there, and the probability is done. Turning this to Avengers Endgame, they did this part almost completely right, because they had to go small into the quantum realm, which is basically quantum mechanics, where you're very small and just atoms. Only they didn't go light speed; they just went to a machine that took them to different times. The way that my time travel theory goes with quantum mechanics is that you have to be small as or smaller than the particles, and you have to go right between the you have to be right before that barrier. You have to go light speed as soon as you hit it, and as soon as you hit light speed, you have to go through, and then it like rips through the hole, or it just rips through the barrier, and possibly leading to a different time. And if you keep going as fast as that, you could possibly end up in a different time. That's my time travel theory. Because time doesn't really, it's just not there. So if you go fast enough, just like the speed of light, and it's just and it doesn't have time, it would just do something. So going back to Avengers Endgame, they did it right. Only they didn't go light speed, and as soon and they had to go small in one time and then appear in the other. No, that doesn't work that way. The only way you would be able to do it, in my theory, is that you go very small and then you just go as fast as you can through the speed of light, go through the boundaries at the speed of light, and I'm pretty sure you could be able to go, if you enlarge back up, you could be able to be in a different time. So yeah, they mostly got that correct. So yeah, that's basically the entire video. I'm about to get my storage wiped out, so thank you guys so much for watching. Hope you liked the video, subscribe, and stay saucy.